Hi, my name is Margaret, and this summer I worked with Worthen Industries to create product carbon footprints for several of their manufacturing products. Worthen Industries is a chemical adhesive and sealant company with a commitment to sustainability. Cradle to grate carbon footprints are the total amount of greenhouse gas emissions it produces throughout its life cycle, from the extraction of raw materials through its distribution. Um, For this product, I created cradle-to-grate carbon footprints for a variety of products and calculated carbon emissions at every step from raw materials through production. The image on the right shows some of the steps involved in this process, including the production, packaging, and transportation. The product carbon footprinting is beneficial as it allows for the determination of where in the process is leading to the highest contribution of carbon emissions. The two main products I focused on this summer included an adhesive used in shoes and an adhesive used on the back of solar panels. I collected data by requesting information from providers, talking to various areas of production, and allocating plant energy data. By speaking with so many different people and collecting all of the necessary data, I got a much better understanding of the entire process of production. At the end of this project, the deliverables included an Excel spreadsheet used for calculations, graphs depicting the CO2 breakdown, and a written report on each product. An example of the Excel spreadsheet work can be seen on the slide. The flowchart on the upper left shows the steps of the process from the purchase and storage of raw materials to the allocated energy used within the production site. The flowchart is useful because it depicts where in the process there's an energy input or a material input to visualize this entire process. You can see that the energy input is indicated by the yellow circle and the material input is the green circle. Allocated energy means that I took the percentage of the total production, that is the desired materials, and applied the same percentage to the total energy used to power the plant in order to determine how much energy was used to create the specific product. The Excel table and the final chart show an example of the product I was distributing internally after the calculations are done. You can see that each individual material's carbon dioxide emissions is calculated by considering the amount of material used along with its individual emission factor. The total grams of the carbon emission is then calculated by adding all of these together. A similar process is completed for the transportation emissions and the total energy. When all are added together, the whole CO2 emission is found. This data was then visualized in a pie chart in order to have a better understanding of the whole picture. You can see an example of this on the slide. I found that the majority of the emissions were coming from the production of different materials rather than the transportation of the total energy, with the total energy used in production being actually the smallest portion in most of the products that I looked at. There are several impacts and next steps that the spreadsheet tool can be used to determine. Mainly, it can be used to determine which stage of this process is leading to the highest CO2 emissions. It can also aid in internal and external decisions about changes in the manufacturing process or CO2 mitigation steps. The product carbon footprint spreadsheet can also be adapted and used in the future for other PCFs, so the setup will stay the same with the values and inputs being changed. This data can also be shared with customers to aid in determining their own emissions. If they are using a Worthen's product that we've already determined the product carbon footprint for, we can send it over and it will help ease their process in determination. Thank you so much. And do you have any questions?